The diehards, all right, you're here. More quantum brain food for us. Hooray, hooray. So we've come to the final two sections of the day. I'm delighted to introduce, again, actually he's already appeared, but Dr. Imed Othmani. He's the global leader quantum computing adoption for enterprises at IBM Quantum. You've probably heard of IBM Quantum. And worth mentioning, you mentioned you've been involved in this like 2018, but IBM's in quantum like 2016 or so. Didn't they put the first cloud-based device like 9 years ago? Just a level set for, you know, the focus that IBM has given this technology over the years, right? Log that. Okay, so Imed's talk is titled Quantum Industry Adoption, the Path to Useful Quantum Computing. So welcome, Imed.
So for the people here, Assalamu alaikum. I speak Arabic, so I will take. Yeah. So I'm really excited to talk about quantum industry adoption here today with you for enterprises. One of the reasons why I'm excited is personal. I started my career as an industrial engineer in the port of Tunis, so in the maritime industry. 25 years ago, I never think that I will talk about quantum application for this industry. So I will, for the next 20 minutes, I will share with you our point of view, IBM point of view about industry adoption, lesson learned, as I said earlier, more than 100 projects from different industry, and how to apply this to maritime. We have some use cases, so make it practical, no? So what is IBM Quantum Mission? IBM Quantum Mission is to bring quantum computing to the world with real business impact. And if we talk about maritime and logistics, Boston Consulting Group estimate that the value that quantum will bring by 2035 is about 100 billion per year. So it's a big number. Now the question is how to make it happen. And there is two ways and two things we need to work on them. First is to develop a large quantum computer that goes beyond classical compute and the platform, not just the quantum computer, but the platform. And this is what we are doing in IBM. The second thing is really you, is the end user trying to explore and find the right use cases. That is not us, it's you, we can help you. So the second question is when will happen? We talked about 5 years, 10 years. We have our roadmap and we have 3 milestones. And I will not talk about the technology roadmap, you can see it. So the first milestone was actually achieved in 2023, what we call in IBM words, quantum utility. What does it mean, quantum utility? We proved that we can run a quantum program on a quantum computer that can compete with classical compute, mainly brute force. That is proven for some specific use cases, right? That is 2023. The next milestone for us is our prediction is 2026 to reach quantum advantage. What does it mean, quantum advantage? And we talk about later a lot of definition. I'm not talking about useful quantum computer that will bring business value, is really to solve with quantum and classical a problem either cheaper, faster, or more precise than classical compute alone. And we believe the first use case will be in material science. And that will be done with the community, not with IBM alone. And the third milestone is in 2029, where we are planning to deliver the first fault-tolerant quantum computer. Why it's important for adoption? Because it will help us to find other use cases that we cannot do now. Now we have a noisy quantum computer, and also increase the benefits, okay? So that is the 3 milestone. Sorry. So returning back to the first milestone, when I said in 2023, we reached quantum utility, how we reached that? in 2023, we went from quantum devices less than 100 qubit, which is, to be honest with you, it's difficult to do something, even a useful POC with them, to 100 qubit system with error mitigation. That's why it's a key milestone. And we have more, we call them 60 quantum devices, 24 quantum computer. We make the difference. But the most important from quantum industry adoption, we put, as you said, in 2016, we put on the cloud the first quantum computer. We are giving access. Actually, anybody can create, go to Qiskit, create an account, and have 10 minutes for free on our quantum computer every month. So, and we run, the end user run more than 3 trillion circuits in our IBM quantum system already. And the reason why is to also understand how we use the system and get the feedback, okay? And we put this system on the cloud, on some on-prem system. We said that sometimes it's important for some company, for some country to have on-prem system, and we have 6 on-prem system in some country, plus Cleveland Clinic, which it's private enterprise. They have their own quantum computer in the cafeteria, okay? That said, for quantum adoption, it's not enough to have a quantum computer. It's important to have an architecture, and we talked about this morning, an architecture where we integrate quantum computer to classical compute. Because we need what we call CPU, GPU, and QPU working together. We call this our quantum-centric supercomputing architecture. In our case, we already started to build this architecture in Japan, where we integrated the Fugaku supercomputer with IBM Quantum System 1. It can be done in the cloud for others, but in this one, they are sitting near each other. And there is a workflow. Behind that, by the way, it's not just the hardware. We build different demo where there is a workflow where we use quantum computer for one task, which is sampling in this case, and all the other tasks are on HPC. And finally, to accelerate quantum adoption, as I said, it's very important to have a fault-tolerant quantum computer, and we are starting already now to build our Starlink, our fault-tolerant quantum computer. It will be ready as internally in 2028, and for the end user in 2029. So you will have access to that. That said, also the other computers that we have, System 2, will be available. Now, returning back to quantum adoption and prerequisite, quantum computer is important, but it's not enough. You know, we have a machine, you need algorithm to run on the machine. So you need to discover new algorithms. We have some, I think we didn't discover all of them. Just this is an example called SQD for chemistry. Why this example is important, actually until 2023 we are working with an algorithm called VQE, and we are limited. We cannot do anything, even we have 100 qubit, we cannot use them. SQD changed the game for chemistry, where we can actually tasks that can take years, we can run them in years, in hours. And the reason why, because we are doing quantum plus HPC. Okay, that is the idea. The same thing for quantum optimization. In the last year, we see a lot of progress on the algorithmic side. Actually, in our IBM Quantum Network, we have a working group from university startup. I think there is some startup are here, Cupo and others, working with us, where we are trying to identify not just the algorithm, but what are the type of problem that we think we can have an advantage. So, and this list is just starting, and it's dynamic list, and we think this type of problem, they are difficult enough, sometimes small enough, and we know they are NP hard and we have some limitation, and quantum computer have a chance to make it happen, okay? Now, we have all this capability. We have the quantum computer, we have the quantum algorithms, how to adopt this technology. And this is where my team role come, where we are mapping the quantum algorithm to industry use cases. As you can see, logistic and transportation is one of the key industry that we are working on. What is the objective of that mapping? Okay, for sure is to help to find which use case is the right one, and as we said, we are discovering new use cases. We are saying this use case is not working, things like that. But the real objective is to help enterprise to start their quantum journey of adoption. Okay, and quantum journey of the adoption, if we can summarize it, it starts with education, evaluating the technology, finding the right use case, and after, when you find the right use case and you decide to invest, then you start to build the future application that will bring you quantum advantage. And that is not enough. You need to start to think about the integration in the workflow of the enterprise. So most of the company, they are here, stage 1 and 2. The company we are working with them, mostly they are here as early adopter. And we believe that next year there is some company will reach some pilot phase if they see maybe quantum advantage, or maybe even without quantum advantage, they need to be ready with some workflow. As I said, we believe that this is not new, it's not because of this conference. We believe that logistics is an important industry, even they are not early adapter as we are hoping. But actually 3 years ago, we rewrote the first white paper on exploring quantum for logistic and for maritime. And we started to build, my team started to build this workflow where we're trying to see where quantum can be applied and how that will have value. Because we need to talk to user and we need to make sure that we have the right target, and working with them is important. So talking about maritime industry, here's some example we believe, and I think it was during the panel, I think Christopher asked the question, what are the use cases? This is just example of use cases. I will not go to the detail, we don't have time. But the first use cases when we're talking with logistic company and maritime company is global and logistic optimization. Global versus local, that is the moonshot. You know, everyone is thinking about that. It's difficult to do right now, but I think it's important to think about it because everything done in silo, even you have the data. The second problem which we find in airlines and maritime is disruption management. You know, you plan something, never, the reality is not the plan. You need to reschedule, and that is difficult. Now the rescheduling is done ad hoc or done with local heuristics, so really not optimal because you need to react in 1 day or half a day or whatever, or 1 hour. So that too is difficult because it's not because it's a large problem, it's because you need to react almost in real time. Now, there is some use cases that we believe that you can start to work on them now, and we start to work on them now, like workforce optimization, like crew optimization, workforce optimization in the port, resource optimization, that is one. Container optimization, storage optimization, that is a big problem that company have. This is from an operation point of view. From shipbuilding, when we discussed earlier, there is 2 use cases. There is more than 2 use cases. One use case is vessel design. I think make it cheaper to do like aerospace or like other doing vessel design is that we believe quantum will help in optimization or CFD or corrosion prevention. I think corrosion is, you know, you put metal in water and salt. Prevention is a huge, and that is a big problem. Actually, in the shipping industry, it's more than $50 billion per year. Let me give you a few examples. So to make this practical, this is a collaboration on marine vessel routing actually is inventory routing. We did this with Exxon actually 3 years ago. That was a foundation paper on maritime routing, where they have more than 500 vessels, and the idea there was to explore how quantum can be mapped with classical, and there is different approach. And believe it or not, after 3 years, the approaches they are there in this paper is worth to read, because the approach can be applied right now. And we stopped at that moment, the reason because the quantum hardware was not big enough. Now we think it is to start to do something, good POCs. But the most important, it's a foundation paper, it's worth to read. Staying in the same theme of routing optimization, this is another work we did with Hyundai Motors. It's not in maritime routing, but could apply to that. I will explain how. It's multi-objective optimization of electrical vehicle. You know, this is the future for them. Self-driving vehicle, electrical, they need to charge, discharge, and bring people in the city, okay? So solving that is important. We know after 200 location is intractable, and the team find a way to decompose the problem that we push the limit under 100 qubit, and we find interesting result. Actually, we reach the level that we are comparable to classical for the Pareto front of the problem, and how this is linked to maritime routing, because in the ports, all the tugboat, you know, the boats that bring the larger vessel, that is something almost similar to that one. Now, the third use case is Woodside Energy. Woodside Energy is an energy company in Australia. By the way, ExxonMobil and all this, we are working them for 5. ExxonMobil actually was one of the first 8 years now working with them. We are still working with them. So they are really Woodside the same. So in this case, workforce optimization, oil and gas, we know for maintenance scheduling on a daily basis for planned and unplanned maintenance is very difficult. Actually, their efficiency in the operation is just 35%. And that is a big problem for them. So any 1% for them is important. To give you an idea about the real problem is about 30,000 variables. We reached the 1,000 in this POC. But still, what we showed that the algorithmic approach is more efficient than the classical, and if the quantum computer improves in performance, this could outperform classical. So that is an interesting result. That is for the operation management. Let's talk about shipbuilding. And I will talk about Boeing because there is a lot of link about airplanes or aircraft and vessels. We started with Boeing also 6 years ago, and I think we are continuing for at least until the end of this decade to reach with them quantum advantage. That is the objective. And one of the first use cases is corrosion, which apply immediately to shipbuilding. And the idea is to understand how corrosion works. Corrosion costs to the economy globally 4% of the GDP is for corrosion, to change the road, to change the bridges, to change the airplanes, to change the vessels. So understanding that, the first company who understand how to prevent corrosion, they will solve a huge problem for the economy. We started small for sure, but I think we have some good idea there to do it. The second use case, actually now we are doing them with them more than 5 use cases, so they have a big team and they have working with the end users. I think that is very important. The second use case I want to talk about is aircraft design. So in this case, we worked with them to find doing simulation optimization for them take for a new aircraft 1 to 2 years for just some part of this program. Okay, imagine that you can do that better, and we find a way to have at that moment the biggest POC. But I think the most important thing is not to take the classical and try to use it with quantum. people were smart. They used what they have, the expertise of the team, because they have expertise. So we put some learning from classical added to quantum, and we have a smaller optimization problem that we have a chance to solve. And that is something very important. And last but not least, I want to talk about electrification. I believe electrification is in any sector, and it's in the ports or in the shipping is important too. We are doing electrification of the grid, in this case with E.ON. E.ON is one of the early adopters in the energy. We started with them like 5 years ago too. And what we did, the first use case we did with them is about energy trading. So, and the reason why I'm talking about that, because you can apply trading to transport too on the price, right? It was energy trading by managing the pricing risk with weather, because we need to have to know if the weather, if the temperature increase, the demand increase and the price increase, and you need to hedge in advance, right? So that is a big risk for them. So we use Monte Carlo to do that, and the idea how to find new workflow. Now we are doing with them a lot of battery work, and this is one of the last one, vehicle to grid scheduling, where demand and supply changes, and you use the battery when there is a lot of demand, you charge the battery when you have less demand. Imagine you have thousands of battery. I think that also is a good example that can be translated to maritime industry. As I said, we have almost 100 projects now done, and we did them with the methodology that we changed over the years, called the quantum accelerator. And it looks like very normal methodology, but there is some details that it makes this methodology work for quantum. And one of the key problems is really finding the right use cases and educating the board. It's not there, but it's in our methodology. So in addition to helping and supporting the individual journey of every enterprise, we know it. It's very, in order to accelerate adoption, you need an ecosystem. That's it. You need either to build it or be part of it. And all our, the enterprise and others are part of the ecosystem. Actually, in IBM, we started that in 2017. We know that the ecosystem is so important that we created the IBM Quantum Network. Now we have more than 300 institutions in this IBM Quantum Network. More 50 of them are industry. We have startup, government, institution, university. This is just examples. Actually, we have a lot of partners here today. Capgemini, Cupo, maybe half of the presenters are from our network, and that is great. And this is important. Why? Because this network, in the last 7 years, they did some of the best research, applied research, 3,000 applied research papers. So the quantity and quality was there. And by the way, IBM is not in the middle. They work together. It's like the 3,000 is very, very few are IBM. What we learned from this IBM Quantum Network, what is the lesson learned? In order to have a successful ecosystem, you need first a mission. What is your mission and strategy? That is normal. But you need 4 pillars at different levels. It depends on your ecosystem. One is research and development. Second, workforce and industry adoption. As a foundation, you need a quantum system, or you need a quantum access to a real hardware, either as cloud or on-prem system. What we know, and we found it in Japan and other, when you put in place on-prem system, it's like a magnet, or like Cleveland Clinic. You put it there, after 2 years, the system is full. It's like, we cannot take any more people. It's like, you put it there and people, I don't know, it's physical. They see it and they want to work on it, but that works. So in IBM Quantum Network, it's actually a system of ecosystem, our network. So we have more than 40 ecosystems that we help build. We support, but actually it's owned and managed by university, by government, by private entity. So that is important. So what is the key takeaway from this short presentation? There is, when I try to do this presentation, I think the first thing, you need to build a quantum strategy for adoption, but does not, if it stays on slide and nobody is taking action, you need to convince and take action with a strategic focus to achieve it. Second and third, they go all together. I think if you want to adopt quantum, you need the real quantum hardware. That is very important. You need the real quantum hardware that at utility scale, the problem of adoption, if you are toy problems, people don't care. If you start to have them all, so you need that. One of the secret sauce I'm sharing here is really industry expertise, algorithm, and business workflow. That, if you have the three of them, and last week we presented HSBC, great result, is because we worked with the end user, with the trader. When you work with the trader, you compete with them, okay? Before the fourth one, I think Olivera said that you need to think differently. If you think you don't, it's a creativity. You need to accept that the results sometimes are unpredictable. You don't understand them, but move on. That's it. That is discovery. And finally, to build an ecosystem. And we'll finish with, I think, the key lesson learned is really a marathon. You cannot win when you start in the last mile. You know, you need to start now if you want to win the marathon. And with that, I will leave you with my last one, which is presentation of the new Starling of IBM Quantum. Thank you. Any question, I'm happy to take. I don't know if you have time. No. Okay. If not, I can take them offline too. Okay.
What could be the resistance to apply or implement quantum?
Resistance when we try to say to someone, to enterprise, yes. Or I think the resistance is, we can wait. Don't start now. It will come. It's not the right timing. That is the main argument I found. But we can prove that I think the early adopters are getting the real results, and we will start to see it now, and it will be a wake-up call. I think in the next year or 2 years, it will be much more easier to convince because they will see the result, and they will say, it's too late. You know?
Sure.
Thank you.
Thank you so much.
Yes, take
Hey, hi, my name is Raghu. Thanks for this presentation. Maybe one question on the Exxon case.
Yes.
So Exxon has been investing for the last 8 years with you,
yeah.
resources, and then they are doing something. But the quantum system still, as we know, has not reached the quantum advantage. So how are they justifying internally as a business case on why they are investing? That's one. And second one is, what do they see as progress since the time they started, let's say in 2017 to now?
Yeah, yeah.
What have they received that will give them an edge over the competitors?
Okay. So we'll talk in journal. I will not talk about Exxon, but I can tell you the real story of company who invest at the long term. You need, the key thing is you need to show progress every year. If you don't show progress, so we did this year, this system is small, we are going to a bigger system, we start to think about HPC and quantum integration. That is difficult when you have HPC we know that. So you show progress and you have a roadmap that change. So I will call it methodological progress toward quantum advantage or quantum value. And that, if you have the right CU and he see progress, and you don't have the exact date, they will accept it because people like Boeing or others, the lead time is 10 years to build an aircraft. They are already late if they don't start. So that is the point. So, but the progress, showing progress is what keeping them investing. And they have an internal roadmap to advantage.
Can you elaborate on the progress part? Like just like you don't need to specify a customer. So what is progress for them? So is it that the algorithm has improved further? Is it that the
Yeah,
performance has
so
improved?
the algorithm or the system of interest they are working on, in the beginning it was one molecule with another, blah, blah, blah. Now with SQD, they can push the limit and they start to have the almost not exact result, but almost the exact result on some system. And now they know where they use this, because it's about energy minimization, when they will use this small task in the overall workflow. And by the way, when they start to workflow, most of the time they work alone because that is very important for them. They keep it for them because that is the secret sauce. So they start to know where to apply quantum. That is a huge progress because sometimes you start and you find the use case is not useless, and you change it. But if you start to find and narrow down the use case and increase that use case and you know where it's in the workflow, blah, 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 I think there is progress for them.
Thanks.
Thank you. Yeah.
So I just want to say too that there's a very detailed roadmap.
Yeah, I hate it. I will call our roadmap is an engineering roadmap. It's not anymore a research.
Sure. But that's the core of how this technology is going to be
Absolutely.
deployed. It's available.
Anything about IBM? I'm here for today. Sorry. Oh. Because we are working on quantum computers.
Well, I think it's your question too, because there's a business.
The future is AI quantum